On today's episode of the Yaesu The Radio Show podcast, we're back for 2025 and our first episode of Season 4, which is going to be a three-part series as to what is Yaesu System Fusion. We're going to give an education to all the people that may have just gotten into Fusion for holiday season. That's for today, Friday, January 3rd, on the Yaesu The Radio Show podcast. And welcome, everybody, to the Yaesu The Radio Show podcast. I'm your host, John Crook. Thank you for tuning in to our episode for the first episode of 2025, Season 4, as we're calling it, Season 4, Episode 1, where we are going back to the basics on this one, is what we'll go ahead and call it, and basically saying, you know what, we're going to talk about what is Yaesu System Fusion, C4FM, FDMA technology. A lot of people this Christmas, and, it's been slowly growing, have gotten into Fusion. But they don't understand what Fusion is. They know it's a digital voice, which we can all assume on there. But they don't understand why Fusion is a very popular digital voice. Why it has better audio performance and characteristics than other digital voice modes. Why does it seem to be more adaptable? Why does it meet those kind of things on there? So we're gonna dive back. We're gonna go into the Wayback Machine on this episode here on part 1 of this 3-part series, and talk about Yaesu System Fusion, the history, where it came from, and what's the core content. We'll go ahead and discuss further in part 2 and part 3 and get you more up to speed to where Fusion is today. But that's going to be for today's podcast on there. Now, before we get into that, people are going to say, John, you're going to talk about Fusion today. You're going to be there. Where can I get information on the Fusion radios that are out there? Yaesu makes a lot of radios. Are all of them Fusion capable? No, they are not all Fusion capable on there. So therefore, we need to go ahead and let you know where some of those radios are at, where you can get the information, manuals, and even guess what? More important stuff on like how C4FM, FDMA, Yaesu System Fusion, want to call that, is not, question comes up all the time, but it is not proprietary. Not proprietary at all. You want that information, head on over to the Yaesu website. That's right there, Yaesu website, yaesu.com. Type that into your browser. Go ahead and under the products, drop-down menu in the upper left-hand corner, right underneath the Yaesu The Radio logo right there, you're going to be able to click on the word digital. Digital is going to take you to the landing page that has all of our current digital radios that are being in production right now or that we support and take care of. But hey, if you have an older radio, let's say maybe you have the FT1, maybe you have the FT2, an FTM 100, 400, whatever the case may be, right underneath that row of pictures on the products digital page of yaesu.com, you're going to see a little tab there that says Archive Digitals. That's where you can go ahead and find all of the older models that are no longer in production, but we still have reference materials and stuff on there. So once again, head on over to yaesu.com and you'll be able to go ahead and find out all that information you need on the Fusion product line as well as Fusion about itself. Alrighty, thank you for tuning in. Like I said, together this episode, I kind of like this. Okay, this is a really cool kind of thing because I started in Fusion when Fusion was just starting out. This was days before I worked for Yaesu, obviously, but it was soon after, only maybe about 2 to 3 years after Fusion, about 4 maybe years, that Fusion really started to get going from the inception that I started to work with Yaesu. And I'll tell you what, it's a really great and fun technology, and it's an easy technology. There's so much better things about Fusion than about the other modes. Now, we're not going to cover that kind of stuff in this episode. Part 1 here is, once again, diving into the history of Fusion, understanding some of the core content and material. So, like, why did we come up with Fusion? Where did it come from? What's the idea? Why we did this? Why we did this? Part 2 and 3, then we're going to start diving more into the how do you use Fusion? What are the different ways you can use Fusion? What do you got to do the first time you get Fusion set up? All that type of information on there. It's going to be part 2 and 3. But today, part 1 is kind of a review of what Fusion was and Fusion has kind of come from the inception point on there. So we're going to jump back in that way back time machine, as I always say, and we're going to go back to 2013. So 2013 is about the time that we started and introduced Fusion to the world. Alrighty? Now, that doesn't mean Fusion wasn't out there before, okay? What we're going to talk about for the concepts and the ideas and everything like that actually started around 2009 to 2010, okay? But the reason it didn't come to fruition until 2013 is because, we had Vertex Standard, we had all that kind of stuff, and then, the Motorola buyout and all that kind of jazz. So 2013 is when we actually were like, here world, here is a digital voice technology. So the idea and concepts we're going to talk about that Fusion has here were actually conceived prior to 2013. So a lot of people think 2013 is when Fusion, this concept was started, and it came out years later. No, 2013 is when it actually hit the market. Now, Dennis Motzenbacher, K7BV, he went along and he was at the Tapper conference, and I believe that year was in Washington State. I believe. It's a long time ago. But at the end of the conference, he came out to talk about a new technology, a new line of products, and that was what we now call or know as Yaesu System Fusion, which was C4FM and FDMA. And I'm not saying which was, it still is, but sometimes people interchange that word fusion and they don't understand where the word fusion came up from. And we'll kind of cover that a little bit, but remember, C4FM, FDMA, and fusion are kind of synonymous to one another, okay, on there. So with that being said, it started with this idea back in 2010, where digital voice was in its infancy, and it's still sort of to a degree in its infancy, but it was really in its infancy there. Right about at that time in the world, you had very few limited digital voice modes out there, okay? You had a very strong line drawn between commercial and amateur. Now, in 2010, you did have some start of some D-Star stuff. Yep, it was out there. But there were issues with D-Star that people had customers that said, I don't like it. I want this kind of thing like that on there. Now, that was the amateur side. But if we go to the commercial side, you had a digital voice technology out there, which was out there since the 90s and was actually adopted and hailed as a great digital voice method or technology, I guess you want to call it, for public safety users. And I think we can all agree public safety users need high quality digital voice. So what we started to do is we started to say is like, okay, we need to bring that concept of digital voice to the amateur world. How are we going to do that? What are we going to do? Well, instead of going ahead and saying, well, here's what's out there, and now let's adopt it, which a lot of people do with the commercial stuff, right? There's commercial stuff out there. Okay, let's adopt it to amateur. How can we make it to amateur? No, we said here at Yaesu, we said we want a digital voice mode that will meet criteria, will meet things on there. And that is where we came up with the 3 key points of our digital voice. Now, people say, oh yeah, the Yaesu System Fusion has 3 key points. Right, but at the time we didn't know we were going to call it Yaesu System Fusion. We knew it had to have 3 key points. The first one was high quality digital voice, right? The voice quality must be the highest level for communication, and the voice cannot be sacrificed. If you are going to use digital voice, right? If you are going to say, hey, I'm going to take this, I don't need a voice sounding like a cell phone from like the mid 90s, right? I don't need to be like, hey, this, you don't need that, right? If I'm going to say, hi, this is N9 UPC and I want it in digital voice, I want you to hear the highest quality of me being N9 UPC, right? If I'm saying that, that's what I want. Because if we're moving to digital voice and it ain't high quality, why do you even bother to have digital voice, right? I mean, really, why do you bother? So that was kind of the first part that we had to do. It had to be high quality digital voice. The second thing that it had to have hands down was it must be easy and simple to use. Okay? No registering with servers, no registering your call sign, no going ahead and getting an ID, no going ahead and programming talk groups or NAC codes or call sign routing or any of that. No, it can't have any of that, right? People want to be able to pick up a radio and use a radio, and that's what it had to be able to do. It had to be able to say, okay, I'm picking up this radio. If I want to talk in digital, boom, I talk in digital. If I want to talk in analog, boom, I want to talk in analog. Now, obviously, there was going to have to be something that was going to have to make it go back and forth, right? So we kind of built that in there with just a simple press of the mode button. But that was the concept right from the beginning. It had to be simple and easy to use. And the third thing, which was hands down, like the 3 rules of Fusion that we had to have, the third one was versatile in usage and operation. If this was going to be difficult to set up, whether that means difficult and set up by the end user, difficult and set up to be used through infrastructure like repeating, or difficult and not easy to use through the setup of like linking or networking, not going to happen, not going to work, okay? There are going to be some things within those things. You can't make it super, super simple and expect it to do multiple things. You really can't. But if you corely concentrate on making it versatile and easy to use, that is going to go a long way. And that's what we said. Hey, high quality digital voice, easy and simple to use, and then versatile in usage and operation. Now we sat back and we said, what do we want to use for this? Because in digital voice, you have a mode of digital, right? Some sort of mode of digital, okay? And then what you have to do is you have to put that mode of digital down an access path of some sort. So really when you're dealing with digital voice, you're dealing with a type of voice technology, how we're going to take our voice that you're hearing me like now and turns it into ones and zeros. What's the format? What's the algorithm? What does it do? Everything like that. So that's the format. And then you need what sometimes will be called channel access or channel management. And that is how we're going to go ahead and send that digital signal down the frequency, right? So the first thing we wanted to concentrate on, and we looked at it and we said, what is out there? What is out there in the realm of the different digital voice modes, if we can say that, or the types of digital voice technology out there? And what we decided on is we decided on using C4FM. Now, why did we go with C4FM? So C4FM stands for Continuous 4 Frequency Modulation. It is basically a play off of FM signal, but what we're doing in this case is we're taking 4 different, in essence, audio frequencies. And in essence, there's really 2 of them, but there's frequency 1 and 2, which is positive, and frequency 1 and 2, but at negative. So what that does is when your voice comes in, it mixes with these 4 different audio points, the C4 part, okay? And then it goes ahead and transmits into a data bit stream on there. Now, the reason we chose C4FM, because there was C4FM out there, there was 4FSK out there. So C4FM, to put it in perspective, what was C4FM? Well, that is like your APCO 25, your P25. They use a C4FM derivative. Okay, P25 is not a digital type mode. Calling something P25 is like us calling it Fusion. P25 uses C4FM and FDMA. Once again, P25, APCO 25, is the Associated Communications of Professional Operators, basically the nationwide organization in at least the United States that set a standard 25, to saying if we're going to use digital voice, it has to meet these methods. Now, the reason they chose C4FM and FDMA is because it uses high quality. The audio response is high quality. You can do things within a C4FM FDMA signal to be able to adjust for audio volume within the radio. You can adjust and everything. But more importantly, it goes ahead and uses a data rate of 9600 baud, or 9600 bits per second. So 9600 bits per second. All right? Not 1200, not 3600, not 4800, but for 9600 baud. Now, why? Why was C4FM designed that way? Because that's going to give you a bigger bandwidth, and that's going to give you more audio quality, right? Bigger bandwidth, bigger audio quality. smaller bandwidth, less audio quality on there. But don't get confused, because there's a bunch of other principles that go into that. So 9600 baud, which is what C4FM uses on there. And then we said, okay, C4FM is frequency shift keying in a way. So that's a proven technology. It's easy to do on there. And then in addition to that, C4FM has that range that's really able to take your voice, whether it be a deep, dark, low voice, or whether it be a high voice. I can't even get that high on the voice there. But it is to really encompass the audio ranges of like 200 hertz to like 3,000 hertz, okay? Then in essence, the whole audio range that we as humans can hear, and it encompasses it. It works well with it. Now, are there things you can do within a radio and the technology to make lows lower, highs higher, whatever the case may be? Yes, you can. We're not getting into that. But that's why we looked at C4FM. The other ones out there, once again, 4FSK, which is DMR-based usage, okay, 4 frequency shift keying, okay, and that does a little more compression on there, and we're like, because C4FM can do 12.5 kilohertz bandwidth. When you start to get in 4FSK, now you start condensing it down a little bit more, okay? But then it was like, okay, well, it has a broader range of audio spectrum. Well, what's the other one out there? GMSK. Well, GMSK is a very old technology that's been out there for a while, okay? And in that case, in that scenario, we was like, no, we want something that's tried and true. Once again, we know C4FM is chosen as the P25 alternative because of high digital voice quality, so why would we not want to go ahead and use that, right? It's been proven. It's been tested, right? C4FM is the standard for public safety. Boom. The decision was made. Now, as we started to take a look into C4FM, we noticed how much of a comparison of the data speeds were starting to come through by using the different modes. So if we did 12.5 kilohertz C4FM, okay, we could almost do 10 kilobits per second per channel. Well, you say, wait, we were 9600 baud. Right. Almost 10. That's that 9600 baud. So we looked at doing 9.6 kilobits per second per channel. Now, analog GMSK sort of almost fit that same kind of principle on there. So this question was, why didn't we do something with analog? Well, because digital voice, the C4FM encompassed that higher quality digital voice. Remember, going back to those 3 characteristics, that high quality digital voice. When you take a look in comparison to D-Star is only doing 4,800 baud, or 4.8 kilobits per second per channel, and analog FSK, so analog frequency shift keying, you're only doing 1,200, so 1.2 kilobits per second. So what is analog FSK? Well, think of that sort of like your packet, right? AX25 kind of on there. D-Star we know, and then analog GMSK, that's almost sort of some packet stuff on there. There are some other different, they're analog, but they're digital voice compression type things that are out there. Most of it deals with like encryption and stuff like that are out there. But once again, it kind of shows, hey, with C4FM at 12.5 kilohertz, we are getting the highest range and the best throughput of, once again, high quality digital voice, which was number 1 on there. So pretty simple, pretty easy. C4FM was going to be the choice. Once again, tried, trued, tested, everything that we needed to go ahead and have on there. Now, we needed a way to send this data down the frequency. That's going to be the biggest thing, right? Analog is 25 kilohertz bandwidth, alrighty? Takes up a lot of bandwidth and channel space, right? One of the things that you really can do with digital, and that's why the FCC, like in the business world, the commercial world, everything, that's why they're pushing people to do narrow banding, and you could do narrow banding in FM, right? But they're really saying rely on digital modes to achieve this factor. Why? Because instantly when you use digital voice, you're going from 25 kilohertz down to 12.5 kilohertz. You can easily scrunch that whole signal into there. And then as you go further and further, depending on how you slice things up, you can go ahead and make the frequencies smaller. Now, there are different types of multiple access technology that are out there. Alrighty? There is FDMA, which is frequency division multiple access. There is CDMA, which is carrier division multiple access. So you might remember those back from the Verizon, Sprint era, the cell phone technologies that are out there, just to kind of give you a reference. They used CDMA. Then there was TDMA, and TDMA was time division multiple access, and that's what DMR uses. But you're not going to really be able to use carrier division multiple access, because what you're doing is carrier, it's kind of taking it, encoding your voice into sequence blocks, and then putting it down the stream there. That's great for cellular, but for voice communications, you really don't need to do that. You're going to have one conversation going at a time. We're not trying to put multiple conversations on a frequency at one time. But in order to go ahead and maintain high quality, maintain that ability to have the greatest and highest amount of stuff that we can have out there, what we needed to do then in that case is we needed to go ahead and saying that, guess what? This is what we're going to head and use on there. So to put it together, it really sort of came down between FDMA and TDMA. Now, the issue we saw with TDMA is you're dividing things into slots, right? So I'm going to give you an example here. What we're going to do is we're going to picture a country road, okay? Nice country road, okay? Big country road, gravel road on there. That's your analog signal, right? Okay, good analogy, because you're driving down the road, you get towards that edge of the road, and then it kind of gets a little kind of like gravelly and stuff like that. You know, your signal gets a little staticky. But now what we're going to do is we're going to come with that gravel road, and that's a whole gravel road, 25 kilohertz in bandwidth. Now what we're going to do is we're going to come in, we're going to do digital, and digital is going to be black topping that road, alrighty? And now once we black type that road, now we're going to paint a line down the center of that road, and we're going to paint lines on the edges of the road, right? We got our yellow lines here, or excuse me, our white lines on the edge of the road and our yellow lines right in the center. So now what do? We have this, we got this road, now we got 2 lanes of traffic. By taking that road, blacktopping it, making it digital, and then painting lanes down there, now we're using FDMA where we're slicing it down the frequency. That's FDMA, folks. What TDMA does, TDMA makes it as time slots. So while TDMA may make the road blacktop and they may have like 2 lanes, what it does though, it doesn't care about the length of the road. What it cares about is equally spacing cars going down the road. The issue with TDMA in that regards is that you have to select a time slot that you're using, and then you're kind of restricted in there because you have the time slots on there. So what you are allowed to fit into a time slot is what you're allowed to fit in a time slot. Where with FDMA, you can push that digital signal down that road, alrighty? And then what you can do is you can adjust the width of that road to be able to go ahead and saying, okay, I can use this much bandwidth, I could use this much bandwidth. It doesn't matter on there. You're not restricted to a bandwidth aspect on there. So that's where FDMA comes in. Now, if we go ahead and talk about it, once again, 25 kilohertz, this nice big road. Then we go ahead and we kind of slice that road in half. We paint that yellow line down it, and now that turns it into 2 lanes. So now we took a 25 kilohertz bandwidth signal, or bandwidth now. We cut that into 12 and a half and 12 and a half. Now what we can even do with FDMA is we can go ahead and make that, cut that lane in half. So now we're taking that 2-lane road, and if the lane's big enough, we're going to put dividing lines down the center of those lanes, and now we took a 12.5 kilohertz lane and made it 6.25. So we have a 25. Now we have two 12.5s, or if we divide those in half, we have 4 6.25 kilohertz bandwidth for the roads. Now, if you're following along on our YouTube channel, you're going to see this example, this graph. I really suggest listening to this podcast on if you're doing a Podbean and everything like that. But if you head on over to our YouTube channel to watch, because there are some good graphics with this on there. But that's where it comes into play, and that's where it's important to go ahead and saying, here's what you need to do. Here's how we're breaking it down with FDMA. We're not restricted to a 12.5 with going ahead and dividing its slots to get that quote-unquote 6.25. No, now what we're able to do by doing FDMA, we're now able to say, you know what, we can just use that full 12.5 kilohertz spacing, or we can now take and we can use 6.25 of that, and then that other 6.25 of that 12.5 we could use for something else. So in essence, now we said, you know what, C4FM, FDMA, that's going to be what we want to use. And once again, who else was using it? Public safety, tried and true method on there. So now that we had this design, this concept of there, now what we needed to do was we needed to start putting together, per se, the algorithm of how we're going to do this. We know we're going to use CDMF or C4FM. We know we're going to use FDMA. But how are we going to make the modes? Remember, the next thing had to be easy, and or I should say well, 2 was ease of usage, right? And then 3rd was going to be versatility on there. So how do we encompass 2 and 3? Because using C4FM and FDMA, we solved part 1. Now we need to do 2 and 3. So the way that we did that is we took a look and saying, okay, we're going to slice it down the frequency. So now what we're going to do is anytime you're using digital voice, you're using quote-unquote fusion, C4FM FDMA by Yaesu, you're going to always use 12.5 kilohertz bandwidth. You're always going to do that. You're always going to do that. Now what we did is we said, okay, let's start out with what do we need to do in order to make the signal the highest quality and have the greatest, in essence, range. And that's where we said, okay, since we're using FDMA technology, remember how we said we can have a 12.5 kilohertz bandwidth, or we can chop it in half, and then 6.25 and 6.25? Well, guess what? That's what we did. And in our digital voice technology, we went along and we took and we put digital voice down one side of the 6.25, and then we put forward air correction, GPS sync and timing, and other parts to help extend that signal down the other 6.25 kilohertz spacing. Then we went along and we said, you know what though? Guess what? Not everybody is going to want 6.25. They're going to want higher fidelity. They're going to want that. Now, will the 12.5 kilohertz voice range versus the 6.25 kilohertz voice range, is that going to go ahead and affect distance? Maybe slightly. The 12.5 is going to have full forward air correction like the 6.25 does, but it's going to be higher audio quality, higher fidelity. And I will tell you, we could play audio clips. You're not going to go ahead and know the difference in the audio clips between some of the different digital voice modes on there. Once again, 12.5 kilohertz fusion versus P25 on there. You're not, because you're going to hear that it's that high quality audio on there. Now, final thing then we said is, you know what? There's going to be times as part of digital voice protocols that we're going to be sending data controlled data, certain things. So we also had to figure out to make a data mode on there. So in essence, we came up with the modes that you now see on a Fusion radio, if you have it, called the DN mode, the VW mode, and the DW mode. Now, the DN mode, we're going to focus in on that right now. The DN mode is that voice mode that takes the 12.5 kilohertz bandwidth, so 12.5 kilohertz lane, and paints a line down the center of it, and your voice is put on 6.25 kilohertz of it, and then the other side is that 6.25 kilohertz of forward air correction, GPS data that can be sent. So if I have a radio that has a GPS in it, when I key up, that GPS data is going to go down that other 6.25 kilohertz channel space on there. And as that progresses, guess what? Guess why? The voice is uninterrupted. It's not impacted. You're not trying to sacrifice data streaming and bandwidth to cram voice and data down that. It separates it into those two lanes. We call this DN. Now, a lot of people say, why do you call it DN, John? Well, we call it DN because it stands for digital narrow. And what we mean by digital narrow is your voice is digitally in a narrow path, 6.25, and then your data is on that other path, not affecting and infecting your quality of that 6.25. So you have the two lanes, two streams. that are going down that 12.5 kilohertz bandwidth. So that is the DN mode. And that tends to be the most popular one, the one a lot of people use, because once again, DN is going to allow the voice to come through. If you have GPS, if you have a radio that can transmit and receive the GPS built into it, I could see the GPS coordinates being sent to the radio, okay? My GPS coordinates are being sent down there. It has the forward air correction on there, so it's going to go ahead and get a little bit of a better range on there and all those aspects on there. Or if we go to our second type of voice mode, now we're talking VW, which is the voice wide mode. Now the voice wide mode is voice only, no forward air correction, no data, no GPS data, nothing like that, but in that 12.5 kilohertz bandwidth there. Full voice, 12.5 kilohertz bandwidth, high fidelity, high quality, 9600 baud digital voice audio coming through there. The purest and best that you can have. Once again, some people say, well, because you don't have that forward air correction on that second 6.25 slot like you do on the DN, it might suffer a little bit. It's not going to be very noticeable in any way, shape, or form on there. But now you have high quality, high fidelity, voice wide on there. Now the second one, or I should say the third one, is actually a data mode. Now this is what we call DW mode, which stands for data wide mode. Now, DN and VW, so digital narrow and voice wide, are selectable by pushing the mode buttons on your radio, okay? But data mode is not accessible. The radio will put it into data mode when it sends certain things. So if you're going to be uploading digital voice to like an HRI 200, if you're going to be sending a text message, if you're going to be sending a picture, if you're going to be doing handshake with the Wires X node, if you're going to be sending Fusion telecommands, okay, so like to a DR2X repeater, something that's going to be strictly data, that's when your radio is going to go into DW mode, alrighty? And when it's in DW mode, it does it, it comes back out to it. So it doesn't matter if you're DN or VW mode. If you got to send something data, it will switch it to VW mode. Okay, DW mode, excuse me, I'm getting my modes mixed up. DW mode, and then it will switch it back to the last mode that you used. Now, great concept. Really great concept. We have the 3 digital voice modes. But we still, to a degree, had one last thing about flexibility and versatility. And this is where Fusion, is what became Fusion, why we call it Fusion, shined. Unlike any other digital modes out there, all the radios, the infrastructure, all that, can operate in digital or analog. You're not restricted to a repeater that can only do digital. You're not restricted to a handheld which can only do digital. All radios can do analog. But wait a minute. There's another problem here, John. You did voice quality. You got that down with the C4FM FDMA. Okay? You got the easy to use. The difference between switching modes, blah, blah, blah. Okay? All you have to do is enter your call sign, hit the mode, you're good to go. We're going to cover that in part 2. So you got parts 1 and 2 done. Number 3, you're not proving me on number 3 yet. Versatility and flexibility. John, you're not proving me on that. Really prove it to me. Okay. Fusion, C4FM FDMA, was designed for the aspect, and why we call Fusion, as I said, to say, hey, I'm a digital user. I don't want to use analog. I've gone to the digital realm. I'm not coming back. Cool, fine. But my buddy over here, he's got analog. You're not going to force me to go to analog. But on the other hand, I'm not going to force him to go to digital. Fair enough. Proper thing to do. So guess what? Fusion is the only digital voice technology out there that is designed to transcode its signal. Now, wait a minute. What do you mean by that, John? Like you're saying, a mobile radio can be set up for sometimes they'll call mixed mode or what we call AMS mode, automatic mode select. Radios can do that. P25 radios could do that for a while. You could have it set, digital signal comes in and decodes digital, and analog signal comes in and comes analog. Yep, correct, yeah. Mobiles, handhelds, all that kind of stuff like that, yep, does that. We're talking infrastructure. We're talking saying, hey, you can set up your repeater to be analog only. You can set up your repeater to be digital only. You could set up your repeater to be AMS, automatic mode select, meaning you're in analog, in digital, out digital. You can also set up your repeater to be able to go ahead and go in AMS. So go in either digital or analog and fix it to come out FM or fix it to come out digital at the infrastructure level. So you can have a digital user come in, the repeater receives it, and then converts it over to analog for you. The analog user can hear you. Now that analog user can come in. That analog user can come in on analog, and the repeater can then spit it out on analog. Or vice versa. You can come in on digital. It goes out on digital. You can come in on analog and convert it over to digital. This is a major point in digital voice technology. And why is that? The other digital voice technologies could not do that, do not do that. So what ends up happening here is you do the 8 a.m. switch, is what I call it. Okay, that's come from public safety era and days. Where you're going and saying, okay, guys, okay, here we go. Okay, we're analog, but Monday morning, 8 a.m., darn it, we're going digital. What's going to happen at 8 a.m.? 8 a.m., we flip the switch on the repeater, and it's digital only. Well, but I don't have a digital radio. Too bad, we're going digital. That excludes a lot of people, right? That's not inclusive. That's not bringing everybody together. That's not making it an environment. The reason we call that, and we say it is fusion, is because it fuses the digital voice technology with the analog voice technology. But now you might be saying, oh, John, that's just on repeaters alone. How are you going to do anything else? No. Part of this concept, is these core concepts we're talking about today, that was implemented in repeater, but even more so, we implemented into Wires X. Wires X allows you to have, in a setup for a mixed mode room, a digital user to come in and go out to digital or analog users. Analog user comes in, can go out to analog or digital users. The preference is up to you. That's the best part. That's that final part there. Not only can the technology do this, but allowing you to determine when you want to do that, how you want to do that, that, my friends, satisfies number 3, which versatility and flexibility. Through the eras of fusion, okay, through the many years that have been out there, people bought that fusion repeater, and a few people have had it in the club or the group or on the repeat, whatever the case may be. And then what they started to do is they started to go and saying, okay, we want to do digital. People want to do digital. I'm not digital. I'm analog. I'm staying analog. Okay, cool. Here's what we're going to do. We could either put it in AMS mode, meaning digital in, digital out, FM in, FM out. And then we're like, yeah, no, I don't like that. So they allowed it, they set it up AMS in, but fixed FM out. And as people started to go ahead and hear that, those FM users were starting to be like, hey, Bill, you're kind of scratchy here. And Bill's like, okay, hang on one second here. Let me switch over to digital. And they go into the repeater on digital, converts it over to FM. Now all of a sudden, bam, they're crystal clear. Because that digital signal is into that repeater. That digital signal is pure in every way, shape, and form. And being converted over to analog. And oh my goodness, that is just amazing. Okay? Then people started saying, okay, well, hey, you know what? Let the digital users talk digital, let the FM users talk FM. If you put a CT CSS tone or your DCS tone on your repeater, the analog users can activate that, and they're not going to hear the digital, the hash buzz, whatever, okay? But then what happened is people started to go ahead and do it. What's even better is that we had some clubs, and I worked with a few clubs that really cemented number 3 on there, was because they had analog users that digital is the devil. They crossed their arms and pouty faces and saying, I'm not going to do digital ever. Okay, great. But then what they did is they said, hey, let's make this deal. Let's take a Yaesu repeater, full digital, wire it into our analog repeater. Very simple and easy to do. The fusion repeaters have recovered analog audio out. So what they did is they wired that analog output into their existing repeater, and what people were finding out is, oh my goodness, you can have a UHF antenna lower on the tower than the VHF antenna, and people on UHF digital, in one case example that I went along, they were almost from the bottom, from the antenna spacing was almost 30 feet down, but the UHF was strictly digital, VHF was strictly FM. The digital UHF users were getting the same range and almost a little bit better than the FM analog users. So that right away in that design of the equipment that we came out, that's how we solidified and made sure that all three of those aspects of what we do in digital voice, high quality digital voice, ease of operation, versatility and flexibility, were met hands down, and is why this mode is easier and very popular over other digital voice modes that are out there. Alrighty. I know that was a lot longer podcast than what we had normally do, and I apologize about that, but I think a lot of core information was on there. I want everybody to go ahead and plan to tune into next week's podcast, which is going to be part 2, and the week after that, which is going to be part 3, where we are going to continue the discussion of Fusion. So this one kind of got into the history of Fusion, where our concept and ideas came from. Part number 2 is going to be kind of the beginning of that setup, how easy it is to get going on there. And then number 3 is going to go ahead and start to talk about how we can use Fusion, how we can do some of those different things that are on there. I want to thank everybody thanks everybody for tuning into this. Once again, as you know, if you're listening on our podcast audio, you're probably listening on Podbean or maybe your famous streaming services. Don't forget to look up this episode on our YouTube channel, Yaesu USA Official. It's got some great graphics in on there. Hey, if you're watching on our YouTube channel, thank you very much on there. Make sure you hit click and subscribe on there to be able to know when a new podcast is going to be released. And if you don't have the YouTube feature or subscription stuff and you want to listen to this podcast, hey, go ahead and turn on and listen to the podcast on our Podbean site. Until then, everybody, take care. Tune in next week for part 2. Stay safe, and we'll catch you on down the log.